one, let's move straight into the repeater room. So let's just update the room. Let's just do my titles. Done. Cool. Right, so let's just do the next one. Let's do repeater room. So welcome to the Burp repeater room. Let's go back and do close tab, make sure I terminated the room. Yeah, cool. Terminate. Right, now I can start this one. Okay, so having covered the basics of Burp Suite, the room will dive into one of the more powerful aspects of the framework, the Burp Repeater module. We'll be covering how to use Repeater to manipulate and arbitrarily resend captured requests, as well as looking at some of the niftier options available in this awesome tool. Finally, we will encounter a series of examples including real-world extra mile exercises which we'll use to consolidate the more theoretical aspects of the room. If you've not used Burp Suite before and you've not completed the basics room, you may wish to do so now before continuing, as the room builds on foundations covered there. Deploy the machine and the attack box. If you're using your own VM, we can just carry on. So what is Repeater? Before we start using Repeater, it would help to have a good idea of what it does. In short, Burp Suite Repeater allows us to craft or relay intercepted requests to the target at will. In layman's terms, it means we will take a request captured in the proxy, edit it, send the same request repeatedly as many times as we wish. Alternatively, we could craft requests by hand, much as we would from the CLI, using tools such as curl to build and send requests. This ability to edit and resend the same request multiple times makes Repeater ideal for any kind of manual poking around at an endpoint, providing us with a nice graphical user interface for writing the request payload and numerous views, including the rendering engine of a graphical view of the response so that we can see the results of our handiwork in action. The Repeater interface will be split into 6 main sections. An annotated diagram can be found below the following bullet points. At the very top of the tab, let's scroll down a bit so we can see it all. Let's make it bigger, there we go. So number 1, at the top we have the tabs. We have a list of repeater requests. We can have as many different requests going through Repeater. Each time we send a new request to Repeater, it will appear at the top of the tab list. Directly underneath the request list, we have the controls for the current request. These allow us to send the request, cancel the request, and go forwards backwards in the request history. Still on the left hand side of the tab, but taking up most of the window, is this bright blue one. We have a request and the response view. We will edit the request in the request view and then press send. The response will show up in the response view. Above the request response section on the right hand side, we have an option allowing us to change the layout of the request and response view by either default side by side, horizontal layout, or you can have them above and below each other as a vertical layout, or in separate tabs, combined view. At the right hand side we have the inspector, which allows us to break requests apart to analyze each of them in a slightly more intuitive way than the raw editor. We'll cover that in a later task. Finally, above the inspector we have our target. Quite simply, this is the IP address or domain which we're sending requests. When we send the request to Repeater from other parts of Burp Suite, this will be filled in automatically. Cool. So basic usage. We know what the interface looks like now, but how do we put it to use? While we can craft requests by hand, it would be much more common to simply capture the request in the proxy, then send it to Repeater for editing and resending. With the request captured in the proxy, we can send to the Repeater either by right-clicking on the request and choosing Send to Repeater, or by pressing Ctrl R. Switching back to repeater, we can see our request is now available. The target and inspector elements are now also showing the information, however we do not have a response. When we click send, the response section quickly populates. If we want to change anything about the request, we can simply type in the request window and press send. Again, this will update the response on the right, for example changing the connection header to open rather than closed, resulting in the response connection header with the value keep alive. We could then also use the history buttons on the right to send the button to go up. We could also then use the history buttons to the right of the send button to go forwards and backwards in our modification history. So capture a request to that in proxy and send it to repeater. We're still using the same box, that's funny. So intercept on, paste in the thing. Do it. Oh, I need to do the, where is it? So we've got scoping, target, scope. We need to get rid of that, because now we've got a different IP. So all of that can go, delete. So now it should block it. Okay, no, maybe not. Let's do a scope, add, and just specifically add it. Okay, so now we get it. Good. So we call this, let's action, send to repeater. We get this view. Right, repeater offers us various ways to represent responses to our requests. These range from hex output all the way up to a fully rendered version of the page. We can see the available options by looking above the response box, which is send, like all of these, look here. So we can see it as raw, pretty, hex, render. Pretty is the default option. It takes the raw response and attempts to beautify it slightly, making it easier to read. Raw is the pure, unbeautified response. Hex takes the raw response and gives us a byte view. This is really useful if the response is a binary file. Render, the render view allows the page to appear as it would as if it was in your browser. While not hugely useful given that we would usually be interested in the source code, it's still a neat trick. In most instances, the pretty option is perfectly adequate, however, it is still worth knowing how to use the other options. Just to the right of the view button, there is a show non-printable characters option, which is the little N. You see all these things appear. This button allows us to display characters that usually wouldn't show up in pretty or raw view. For example, every line in the response will end with the characters /r or \r/n. These signify a carriage return followed by a new line and a part of how HTTP headers are interpreted. While not required for most tasks, this is still handy. So which view option displays the response in the same format as your browser would? Render. So the inspector, in many ways, inspector is entirely supplementary to the request and response fields of the repeater window. If you understand how to read and edit HTTP requests, then you may find that you rarely use inspector at all. That said, it is a superb way to get a prettified breakdown of the requests and responses, as well as for experimenting to see how changes made using the higher level inspector affects the equivalent raw versions. Inspector can be used in the proxy as well as in repeater. In both cases it appears over the very right hand side of the window, gives us a list of the components in the request and response. Of these, the request sections can nearly always be altered, allowing us to add, edit, and delete items. For example, in the request attributes section, we can edit the parts of the request that deal with location, method, and protocol, e.g. changing the resource we're looking to retrieve, altering the request from GET to another HTTP method, or switching from a different protocol, so HTTP1 to HTTP2. So yeah, you can change things like the headers, response headers. The other sections available for viewing and or editing are query parameters, which refer to data being sent to the server in the URL. For example, in a GET request, there is a query parameter called redirect with a value of false. Body parameters, which do the same thing as query parameters, but for post requests, anything that we send as data in a post request will show up in this section, again allowing us to modify the parameters before resending. Request cookies contain, as you might expect, modifiable lists of cookies which are being sent with each request. Request headers allow us to view, access, modify, including outright adding or removing any headers being sent by our requests. Editing these can be useful when attempting to see how a web server will respond to unexpected headers. And response headers, this shows us the headers the server has sent us back in response to the request. These can't be edited as we can't control what headers the server returns us. Note that this section will only show up after we've seen a request and received a response. These components can all be found as text within the request and response section. However, it's nice to be able to see them in a tabular format offered by Inspector, as well as it's well worth adding, removing, editing headers in the Inspector to get a feel of how the raw version changes as you do so. Let's just pick one at random then. So let's change close to open. So look here. Send. Now let's keep alive. Alright, practical. Repeater is best suited for the kind of tasks where we will need to send the same request numerous times, usually with a small change in between requests. For example, we may wish to manually test for a SQL injection vulnerability, which we'll be doing in an upcoming task, attempt to bypass a web application firewall filter, or simply add and change parameters in a form submission. For now, let's start with an extremely simple example using Repeater to alter the headers of a request we send to the target. So we need to capture a new response, a new request even. And we send it to Repeater. So action, Repeater. Send the request once from Repeater. You should see the HTML source for the page you requested in response. Try viewing this in one of the other view options, e.g. rendered. Using Inspector, or manually if you prefer, add a header called flag authorized. And its value true. So send that, and we get a flag back. Okay, so in the previous task we used the Repeater to add a header and send the request. This should serve as an example for using Repeater. Now it's time for a very simple challenge. With your proxy deactivated, head over to Products, Okay, and by clicking some of the see more links, see more. Did you notice that it redirects you to a numeric endpoint? So 1, 2, 4. This endpoint needs to be validated to ensure that the number you try to navigate to exists and a valid integer. However, what happens if it's not adequately validated? So I'll just keep going up. 6. So we get 404, 0, 404, 404. Guess we can start putting some random stuff in there. So capture a request to one of the numeric product endpoints in the proxy and forward it to repeater. Let's go to free. So turn it on, refresh, Control R. See if you can get the server to error with an 500 internal server error code by changing the number at the end to some extreme inputs. So let's get rid of some of these older ones. So where's the endpoint? There it is. So if we change 3 to millions, we still get 404. Let's keep going. 404. Minus 1, 2, 3. Hey, there we go. So we give it minus values, then we basically it's not an integer anymore, so it spits this out. Can I copy from the render? Okay. Right, SQLi with repeater. So this task contains an extra mile challenge, which means that it's slightly harder real-world application for Burp Repeater. If you feel comfortable performing a manual SQL injection by yourself, you may skip to the last question and try this as a blind challenge. Otherwise, a guide will be given below. Before we start on this challenge, if you don't already know the principles of SQL injection, it would be well worth your time to check out this room on the topic. Of course, a subscription room. Of course it is. Let's just copy link. So I'll put it in chat if anyone's got a sub. However, full steps will be provided, so you don't need in-depth knowledge of the principles behind SQL injection to complete the task. This brief is as follows. There is a union SQL injection vulnerability in the ID parameter of the about ID endpoint. Find this vulnerability and execute an attack to retrieve the notes about the CEO stored in the database. We know that there is a vulnerability and we know where it is. Now we just need to exploit it. Start by capturing a request to here. Let's do that again, right. Okay, so we've got that. Now that we have our request primed, let's confirm the vulnerability exists. Add a single apostrophe is usually enough to cause the server to throw an error with the simple SQLi is present. So either using Inspector or by editing the request path manually, add an apostrophe after the two. And we get another error. And a nice printout of the SQL statement. So add the apostrophe and we get the request out. You should see the server responds with 500, indicating it broke the query. If we look through the body of the server response, we'll see a very interesting around line 40, the server is telling us what we tried to execute. This is extremely useful error messages, which the server should absolutely not be sending us. The fact we have, it makes our job significantly more straightforward. The message tells us a couple of things that will be invaluable when exploiting the vulnerability. The database table that we're selecting is called people. So there. You see that with my head in the way. The query is selecting 5 columns from the table: first name, last name, PFP link, role, and bio. We can guess where these fit into the page, which will be helpful for when we choose where to place our response. With this information, we can skip over the query column number and the table name enumeration steps. Although we've managed to cut out a lot of enumeration required here, we still need to find the name of our target column. As we know the table name and the number of rows, we can use a union query to select the column names for the people table from the columns table in the information schema default database. A simple query for this is as follows. So this creates a union query and selects our target, then all 4 null columns to avoid querying error out. Notice that we also change the ID that we're selecting from 2 to 0 by setting the ID to an invalid number. We ensure that we don't retrieve anything from the original legitimate query. This means that the first row returned from the database will be our desired response from the injected query. Looking through the return response, we can see that the first column name ID has been inserted into the page title. So do we need that as well? Yeah, cool. Okay. So now we're getting ID none, none, none. We've successfully pulled the first column name out of the database, but we now have a problem. The page is only displaying the first matching item. We need to see all the items. Fortunately, we can use our SQLi to group the results, which we can still only retrieve one result at a time. But by using the group concat function, we can amalgamate all of the column names into a single output. Send that. So if we scroll back down to the line, okay, so now we get them all. So this request is shown below, or on my screen. We've successfully identified 8 columns in this table: ID, first name, last name, PFP link, role, short role, bio, and notes. Considering our task, it seems a safe bet that our target column is notes. Finally, we're ready to take the flag from the database. We have all the information that we want. The name of the table, the name of the target column, notes. The ID of the CEO is 1. This can be found by simply clicking on Jameson's Wolf's profile in the About page and clicking the ID of the URL.
Sharma_G_ says,
MSec, can I share a link in chat? Quite a big update for me. Got my research paper published in Springer. Little 589 Teddy Dance.
Oh, awesome. Yeah, if you put it in chat, it will get deleted when you post it, but I'll copy it. I'll be able to see it. So yeah, fire away.
Web link.
Nightbot says,
As Sharmaji, greater than justice delivered. Stop posting links. Warning.
There's your link.
MSec says,
Web link.
Perturbation by civil attack in clustering for open IVC networks. Oh, yeah, that's so over my head, I can't. I'd have to look at that abstract a lot more. Right, what we're doing. Oh yeah, so we're doing the SQL. So let's get rid of all of that. So we're unioning all. Select notes, and then null, null, I need a load of nulls. So notes, no, we need 8, don't we? So null from people where ID equals 1. D equals 1. Something like that. Got one extra null. Okay. And I bastardized the thing. So okay, so then we get the flag out. So room conclusion. So we've now completed the Burp Suite repeater room. You should hopefully now understand how to use repeater to edit, manipulate and resend a request, as well as having an idea about how the many practical applications for this. The next room in the module will go on to look at the Burp Suite intruder tool. Okay. And intruder is a subscription, damn it. But yeah, intruder's cool because then you can start sort of messing with the repeater, but like all of these parameters get sort of triggered automatically. So we'll have to come back to that when I do a subscription box.